Okay, so we're going to take a look at example number 5, interpret intercepts from section 7.2, the general form of an equation. So Spencer has 66 gigabytes of disk space left on his laptop to fill with television shows and movies that he purchases online. Suppose a 1-hour show uses 1.1 gigabytes of disk space and a movie uses 4.4 gigabytes. Write a linear equation that represents the number of television shows T and movies M that Spencer can store on his laptop. Okay, so we know that our variable T is going to be the number of television shows, and we know that our variable M is going to be the number of movies. Spencer has 66 gigabytes of disk space total, and every 1-hour show is 1.1 gigabytes, and every movie uses 2.4 gigabytes. So our equation will be 1.1 times T, the number of television shows, plus 4.4 times M, the number of movies, to give us 66. We're going to put it in simplest form. So the first thing we will do is we will multiply the whole thing through by 10. So that means every term inside the bracket gets multiplied by 10. So 10 times 1.1 is 11. 10 times 4.4 is 44. And 10 times 66 is 660. And then if you look at it closely, you can see that every number is divisible by 11. So we are going to divide everything through by 11. And you get T plus 4M equals 60. Okay, the other way you could do this is by noticing that every number in our equation is divisible by 1.1. So we could do this, and we would get the same thing. 1.1 divided by 1 is 1, so 1t. 4.4 divided by 1.1 is 4, so 4m. And 66 divided by 1.1 is 60. Okay, so this is our equation. Okay, determine the t-intercept of a graph of the linear equation. What does the t-intercept represent? Okay, well, our equation is t plus 4m, which is equal to 60, and our t-intercept occurs when m equals 0. Okay, so that means in place of m, we are going to put a 0. Okay, so 4 times 0 is 0. That leaves us with t equals 60. And because t stands for the number of television shows that Spencer can upload or download onto his laptop, it would represent the number of movies that he can store on his laptop if he doesn't have any the number of television shows that he can put onto his laptop if he doesn't have any movies. Okay, so the t-intercept is 60. If Spencer stores no movies, he can store 60 television shows on his laptop. Okay, next question. What would the m-intercept be? And what does the m-intercept represent? Okay, well, the m-intercept happens when t is 0, right? So the m-intercept occurs when t equals 0. Okay, so we'll write out our equation again. T plus 4m equals 60. We want to put in 0 for t. So we get 4m equals 60. Divide both sides by 4, and we get that m is 15. All right, well, what does that mean? Well, M stands for the number of movies he can store on his laptop. So if he has no television programs, he can put 15 movies on his laptop. Okay, so the M intercept is 15. Spencer can store 15 movies on his laptop if he does not store any television programs. Okay, I just want to check the one from above, make sure I wrote that down. So Spencer stores no movies, he can, yeah. Okay, so the last question then, if Spencer stores 16 television shows, how many movies does he have space for? Okay, well, what you can do then is start with your equation again. If he stores 16 television shows, that means that t is equal to 16. So in place of t, we're going to put 16. We're going to solve for m. So we're going to minus 16 from both sides. And we get that 4m is equal to 44. Divide both sides by 4. And we get that m is equal to 11. Okay, so that means that he can store 11 movies. So Spencer can store 11 movies if he stores 16 television shows. Okay, so that concludes this example.